Hey guys, happy Wednesday. Today's day 2 of chapter 23. We're going to continue our talk about sample means. Okay guys, here we go. So just a reminder about your homework. Please do these practice problems. They're a great resource. Check out your calendar daily, please. I am thinking of having a quiz on Friday for you all. We'll see how it goes. Okay, I'll give you a more definite answer pretty soon. Not sure what that quiz is going to look like, but do your homework, please. Yesterday, I mentioned that there are 2 things we need to accomplish in this chapter. We talked about, T curves versus normal curves or Z curves. And we talked about how we're going to do confidence intervals and hypothesis tests for one sample means. Remember, past chapter was proportions. We did a 1 proportion, then a 2 proportion. Now we have 1 sample mean. Another word for mean is average. You all know that. So let's start on page 525 to 526. There are certain conditions and assumptions we need to go over. Now, remember with proportions, it was certain, right? SIR 10. But do you guys remember way back in chapter 18 when we did sample means? It wasn't certain, but it was actually Nerton. Okay? Now, the IR10 are the same. So I'm just going to leave this as independence. Hopefully you guys have memorized this by now. Right? Each, whatever we're sampling, each car is independent, each person, each student is independent of one another. And same thing with randomization. Okay. We assume that each car, each person, each student was randomly selected, and then 10%. Right, we want to make sure our sample is less than or equal to 10% of the population, whatever that is. So if we're sampling cars, we just want to make sure that the number of cars in our sample is less than or equal to 10% of the entire car population. All right. Oh my gosh, what am I doing? I didn't even talk about N. So N is what we call the nearly normal condition. And you'll see it on page 526, right here. So what we're saying is that we're saying that the population that the sample came from is nearly normal. Remember, normal is this, right? The bell-shaped curve right here. So we're saying the population that the sample is taken from is approximately normal, or we could say nearly normal. Now, the interesting thing for this is if given data, like see number 33 from your homework, if given data, must draw the distribution, and this could be as a histogram, as you'll see on page 527. If you flip to 527, they draw a histogram right here. I think histogram is probably the most common way, and you can just do that on your calculator and just sketch it. It doesn't have to be exact, just sketch it. Okay, as you guys can see, the one on 520, oh no, my phone. The one on 527 right here is nearly normal, right? We'd say that's nearly normal. You must draw it, okay? If not given data, we just assume, okay? You could just say that we assume that the population is approximately normal or nearly normal. All right, let's do it. So yesterday, we kind of wrote this out. Remember, we are now talking about confidence intervals. CI stands for confidence intervals. 1 proportion was this. Now this is for mean, so I'm just going to cover this up. Okay. If you guys remember, this is the mean plus or minus the T critical value given degrees of freedom times our standard error formula, which is on your formula sheet, S over the square root of N. Okay. So let's try that here. So we're going to go to page 543. This is not one of your homework questions, but it's about hot dogs, and we all love hot dogs. go ahead and read number 15 to yourself. You can pause the video, and then when you're working on that, can you just write down your given information? And I'll give you a hint. You should have your mean of the sample, you should have your standard deviation of the sample, and you should have the n and also your confidence level. Go ahead and pause the video and find those 4 things. Hot dogs. Where's your favorite hot dog from? I would say the best one comes from Costco. I wouldn't go right there right now, obviously. Toilet paper mania. But $1.50 and a drink, man, life is good. Life is good. Okay, so we have the mean sodium content. We have a sample of 40 hot dogs, and the mean sodium content is 310 milligrams with a standard deviation of 36. Wow, that's a lot of sodium in a hot dog. Okay, and a confidence level when we look at part A is 95%. So we want to use that same formula that we've written on the other page. Our confidence interval equals our mean plus or minus. Now this is our margin of error formula, T critical value, degrees of freedom, times S over the square root of n. Standard deviation over square root of n. Okay, just a reminder, right? A confidence interval right here. If we have a mean of 310, we know that this x bar is 310. So we're looking for the lower bound and the upper bound of our interval. Okay. By the way, on your chapter 21-22 quiz that you took last Friday, I loved how you guys drew this out. And I hope that helped you answer that one question of, based on your interval, is there evidence that blah, 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 blah. Okay, so our T critical value, our degrees of freedom, since it's 40 is our sample size, our degrees of freedom, remember, is n minus 1, so it's going to be 39, times, we have our standard deviation of our sample, which is 36, and we have our n, square root of, square root of 40. Okay. All right, so we have 310. Now we have to find the critical value of degrees of freedom of 39, so I'm gonna go to my textbook. Remember, you can find this online as well. It's right here. So I don't know if you can see that. We want 95%, and we want to find 39 right here. So there's 30, 32, 35, 40. Wait a minute. There is no 39. What am I to do? So just guesstimate. So we could do that. We could use 40, the 2.021, or we could use technology. We could use our calculator. So let's do that. So do you guys remember where we go? It's either inverse T or TCDF. Which one was it, guys? It was inverse T. So we're going to go second vars inverse T. And since it's 95 degrees, that means our area is going to be 0.025. Our degrees of freedom is 39. Paste. And remember, we want the positive value of this. It's going to be 2.022 or 0.23. And that's really close to the degrees of freedom, the critical value for 40. So it's 2.023 times, let's see what 36 divided by the square root of 40. 5.692 times 2.023. 310 plus or minus 11.52. Remember, this part right here is what we call our margin of error. Okay, so that means our interval is gonna be 298.48, 321.52. Okay. So remember, this is by hand. So let's just see how to do this. So this is by hand. Let's do it by calculator. By calculator. And then the instructions for this is on page 529 to 530. There are actually two types that you could use this for, and I'll show you. Okay, so this is going to be stat, test, and it's option 8. 8, I think it says T interval. So let's go there. Stat, test, T interval. So it's option 8. And then look, you'll see data and stat. So right now we have statistics. We don't have the actual raw data. Do you guys remember the difference between a statistic and data? Data is the raw ingredients without being cooked up. Once it's cooked up, like once you find the mean or standard deviation, that's a statistic. Okay. So I'm gonna input my mean, 310, 36, 40, confidence level of 0.95. I'm gonna hit calculate. And let's see if we get the same answer. Hey, what do you know? We did it. 4-1, 4-1, 5-1. Okay. Just off a little bit, it's okay. So our interpretation here, we have to write, I am 95. Now this does not change at all from what we did in our past chapters. 95% confident that the true mean, not true proportion, true mean sodium content of reduced sodium hot dogs. Man, if this is reduced sodium, I wonder how much sodium is in regular sodium hot dog. So content of reduced sodium hot dogs is between 298. I'm going to use the calculator one because this is more exact. And oops, we don't need this. 321.51 milligrams. Okay, I am 95% confident the true mean sodium content of reduced sodium hot dogs is between 298.49 and 321.51 milligrams. Voila. Okay, so this is only part A. So we just finished up part A. Let's take a look at part B here. So part B is asking us, what assumptions have you made in this inference? What are the appropriate conditions satisfied? So if you go down Nerton, okay, so did we assume that it's nearly normal? Do we have the raw data? We did not, right? So we assumed the population is nearly normal. Independence, do we know that hot dogs are independent? You know, the hot dogs could have been made at the same factory by the same maker with using the same meat. You guys know what hot dogs are made out of? It's like never mind. You can look that up yourself. We assume each hot dog is independent. So basically, we assumed everything, right? We assume each hot dog was randomly selected or chosen. We assumed that 40 hot dogs is less than or equal to 10% of hot dog population. Class, do you think there are less than 400 reduced sodium hot dogs out there in the world? Probably, right? So we assumed all of these things here. And then part C, it says clearly explain what your interval means. This is the same thing. Look at your template on your on your formula sheet, the sentence frames, right? If there are several samples taken, we expect 95% of those samples to contain the true interval of mean sodium in reduced sodium hot dogs. Okay. So let's take a look at number 33, which is from your homework. I'm not going to do it for you, but you're going to do it yourself. It's about Chips Ahoy cookies. This would be a great study to do. Maybe you all should do this at home right now. So number 33 is about Chips Ahoy. But the interesting thing about this is one is it's given data. Okay? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So your n here is 16. But you're given the data, so this time what you're gonna do, I hope you can open up your textbooks, pause the video, and go take a look at number 33. You're gonna go to the same place. If you're gonna do this by calculator, you're still gonna go to stat, test, 8, t interval. Stat, test, t interval. Now notice you'll see an option that says data. You're gonna click on that. Okay, and then you're gonna specify which list you're gonna pull that data from. Now, remember when you put in lists before when we were working with linear regression? So in your L1 or whatever list you want to call this, you're going to put in those values that are listed in your textbook, okay, etc. There should be 16 values right there. Once you put that in, you're going to go back here and you're going to say, I'm using my list 1 or whatever list you want to choose. In the same way, you just hit calculate and then voila, you'll get your answer, okay? All right, have fun with that. I will see you tomorrow. Bye-bye. Oh, one more thing. If by the end of today, so by Wednesday, March 18th, if you would email me and tell me your favorite type of ice cream and why, I will give you 2, I like that, 2 extra test points. Okay? Keep it on the down low though, okay? Keep it low key, don't tell other people. Oh, and if you can guess my favorite ice cream flavor, I'll give you an extra 1. So 2 points, you tell me your favorite ice cream flavor and why, and then 1 point if you can guess what my favorite is. Bye-bye.